InterChain Transactions, InterChain compatibility and composability, InterChain applications are the next major feature that any blockchain will need to have unless they want to disappear. The following demo is done with tools from the Cosmos ecosystem, but if Ethereum 2 will implement the IBC precompile that I demoed in a previous video, then today's example could be possible also on Ethereum. Bridging these two ecosystems, Ethereum and Cosmos, will bring the next generation of blockchains: modular, flexible, and interconnected. Cosmos has recently added InterChain accounts to its SDK. This means you can use one Cosmos chain to control a shadow account on another Cosmos chain. InterChain accounts can be used now with any Cosmos transactions. So a user can make InterChain transactions limited by what the blockchain developers have decided as features for those particular blockchains. But today I'm showing you a prototype of how you can use InterChain accounts for EVM-powered Cosmos chains. This is the first time anyone designs and implements such a demo. The Ethereum virtual machine gives freedom and responsibility to any developer to use InterChain transactions. And you will see part 1 of a replay bridge smart contract built on a fork of Evmos with InterChain accounts integration and an InterChain accounts precompile. So any contract could use this InterChain account precompile with the security measures that we will talk about in a later video. This is a diagram of the prototype that you will see next. A normal user, an externally owned account, or a smart contract, like the bridge contract mentioned earlier, uses the InterChain accounts precompile to send a transaction. We are on chain 1, and we want to send a transaction on chain 2. This transaction is sent by the precompile to the InterTX module, still on chain 1. This is a Cosmos module that I programmed. The InterTX module signs this EVM transaction with an abstract account that corresponds to the InterChain account of the account that triggered the transaction in the first place. After it signs it, it wraps the Ethereum transaction into a Cosmos message and submits it to the InterChain accounts module to be then relayed by IBC to chain 2. On chain 2, the message is received by the InterChain account module and then sent to the InterTX module, where the Ethereum transaction message is unwrapped and then sent to be processed by the EVM module. The gas needed to execute the transaction on chain 2 is paid from the InterChain account balance of the original account that sent the transaction. The receipt is then sent back to chain 1 and to the account that triggered the transaction. And this is the demo. I have two Evmos chains here, a controller chain on the top, chain 1, and a host chain on the bottom, chain 2, and a relayer between them. And I have an InterChain account already created between the chains. I have a bridge contract deployed on chain 1, Evmos 9001, and a target contract deployed on chain 2, Evmos 9002. And we will copy the address for the target contract. And we can see that the target contract has a state with a value of 0. We will be changing this state with an InterChain transaction from chain 1. For demonstration purposes, this example is made to be flexible. We take the target contract address and the chain ID for the second chain, a value of 0, gas limit of 100,000, and the call data that we want to run on the target contract on chain 2, which calls the set function with a value of 2. We trigger the transaction. And we see the IBC packets being relayed and being processed. And now we get a value of 2 on the second chain. You have seen a prototype for sending transactions from one EVM chain to another. It uses InterChain accounts and IBC, and this can be used as a base for trustless bridging, state mirroring, multi-chain dApps, multi-chain singleton operating systems, and usable by Ethereum 2 with the IBC precompile.